All right, let's try and run through these problems real quick that I put into the Schoology folder. Practice problems 2, all basically revolving around density. So here's our density formula. Density is mass over volume. And we have, what is the density of an object that has a mass of 225 grams? That's the mass. And a volume of 90 cubic centimeters. That's the volume. So let's write it again. And it really helps if you just write everything out so it avoids making mistakes. 225 grams over 90 centimeters cubed. That's a horrible looking zero. There we go. Now, since there is nothing to cancel out in the units, then our answer has to be in grams per centimeter cubed. And then you can just take your calculator and punch your numbers in. So calculators work better when they're turned on. We've learned that. 225 divided by 90, and you get 2.5. So the density of that object is 2.5 grams per cubic centimeter. All right. Next one. What is the density of a cube that has 4 centimeter sides and a mass of 320 grams? So again, density, mass over volume. Density is mass, which is 320 grams, 0.0, over the volume, which we know it's a cube, and it has 4 centimeter sides. So cubes have all the same dimensions. So the volume of a rectangular solid is length times width times height. And since it's a cube, length, width, and height are all 4. So 4 times 4 is 16, times 4 is 64 centimeters cubed. Then you just do 320. Again, take your calculator. 320 divided by 64, and you'll get 5. And then grams divided by cubic centimeters is grams per cubic centimeter. So that's your answer. All right. Let's look at number 3. All right, now we got a little something different here. A student has a graduated cylinder with 50 milliliters of water in it. He then places a 150 gram stone in it. After it settles on the bottom, the volume of the cylinder is 125 milliliters. What is the density of this stone? So, density, mass over volume. Density, mass is 100 grams, right? Or 150 grams. 150 grams over the volume. So what's the volume? Well, we started with 50 milliliters of water, and then when we put the stone in there, it went up to 125. So 125 minus 50 is 75 milliliters. So you end up with 150 grams divided by 75 milliliters, and that is 2 grams per milliliter. And if we remember milliliters equal cubic centimeters, you could say grams per cubic centimeter as well, because they're the same measurement. But the density is 2. All right, let's look at the next one. Get that paper out of there. Let's actually pause for 1 second here. Okay, we're back. Now we have a 2-part problem here. If a block of wood has a density of 0.75 grams per milliliter and is placed in water with a density of 1 gram per milliliter, then answer the following questions. What is the percentage of the block that will be above the water? So the way this works, and this works really conveniently for when you put things in water which has a density of 1. So if the density of the object is 0.75, so it's less than 1, so that object is going to float, then 75% of it is going to be underwater. So the denser these objects get, like here's a cube I was using as an example in class, and we said, let's just hypothetically say this cube had a density of 0.8, and you placed it in water, whose density is 1, then 80% of that cube would be underwater, and 20% of the cube would be above water, or the rectangle here, this box shape. So you don't even have to do any math here, other than to say like, okay, 75% is below the water. What percentage is above the water? It's got to be 25%. Then they say if the block has a mass of 600 grams, how many milliliters of water will it displace? Well, that's easy. It's going to displace 600 milliliters of water because the density of water is 1, and the weight of the displaced water has to be equal to the weight of the block for it to float. If the block was heavier than the water it displaced, then the block would just sink to the bottom because its density would be greater than 1. But because the density is less than 1, then the weight of the block is the same as the weight of the displaced water, but the volume of the displaced water is only 80% of the volume of the block. So you don't even need to do any math for this. If the density is 1, if it's water, there's no math to be done. Since the density is 1 gram per milliliter, it's going to displace 600 grams of water because the block weighs 600 grams, so that's 600 milliliters of water that's going to be displaced. Real simple. And then now we get for the enrichment classes, they have to do a little more math on this. We want to know what the volume of the block is. So we know that the block displaced 600 milliliters of water. So, and the density of the block is 0.75. That was in the previous problem. So if the block is 0.75, and we want to know what the volume of the block is, we can rearrange the density formula. Density is mass over volume to be volume equals mass over density. We can bring this over here and put it in the numerator, and bring this over here and put it in the denominator. You multiply both sides by V, and then divide both sides by D, and that's how you rearrange that and end up with this formula. So the volume equals the density, and that's in grams per milliliter, divided by the mass, which is going to be 600 grams. So grams are going to cancel out, and then you've got a denominator in the denominator, so that will put it into the numerator. And if you want me to explain how that works, that'll probably be a whole other video. So we have 600, so we'll turn our calculator back on, and we'll just do 600 divided by 0.75, and we're going to get 800. So the volume of the block is 800 milliliters or 800 cubic centimeters, because again, they're the same thing. It's the exact same thing. And then question 4 says, what is the volume of the part of the block that's above the water? So 25% of the block is above water. So what's 25% of 800? It's 200. Because I can take 800 and multiply it by 0.25, because that's 25%, and you get 200. And it's 200, they want volume, milliliters, or 200 centimeters cubed. Either one works that way. Okay, I hope this helped you out. Please, if you're one of my students, email me with any questions. If you're not one of my students, if you're not one of my students, you can email me too, and I'll try and help you out. Hope you have a good day.